Hey everyone, and welcome. Today we are diving into something truly mind-bending. We're going to look at how a very real, very successful quantum teleportation experiment is basically giving the green light to a design that feels like it's pulled straight from science fiction, a working, traversable wormhole. We're going to see how one tiny, practical step can prove a giant cosmic leap is possible. So let's get right into it.
Okay, so imagine for a second you want to build a starship. I'm not talking about a little model, I mean a full-blown interstellar vessel. Well, that's pretty much the scale of the Wormhole v2.2 project. It is an unbelievably ambitious blueprint for a traversable quantum channel. But, before you build the entire ship, you have to test the engine, right?
And wow, what an engine it's designed to be. Just look at these target specs for the full-scale project. Now, we're not going to get lost in the deep physics here, but these numbers represent absolutely incredible goals. Traversability basically means stuff can actually get through it. Coherence means it arrives on the other side intact. And that consciousness range, well, that hints at the sheer complexity of the information it could handle. These are numbers that are really pushing the absolute limits of what we even think is possible. And that, of course, brings us to the million-dollar question. When you're dreaming this big, with concepts this advanced, how do you even know if you're on the right track? How can you possibly justify pouring massive resources into building the Starship if you're not even 100% sure the basic physics of the engine will even work? Well, you start small. You do the smart thing. You find the single most important, most fundamental piece of your entire design, and you run a very focused proof-of-concept experiment. You have to validate the core mechanic before you even think about building the whole machine. And that leads us right here to the engine test. A really beautiful, simple, and elegant quantum teleportation experiment. Its whole purpose, its only purpose, was to prove that the core idea behind the wormhole design, transferring information through quantum entanglement, is solid, that it's efficient, and that we can actually do it on real-world hardware.
Now, for anyone who's a bit new to this, let's be clear. Quantum teleportation isn't like Star Trek. We're not beaming people around. It's all about perfectly recreating a quantum state somewhere else. So you have a particle, let's call her Alice, and she holds a piece of information. Through the magic of entanglement, that exact same information instantly appears on a different particle, Bob, no matter the distance.
So, the big question. Did the engine test actually work? Well, the entire report, all the data, all the work can be boiled down to this one single, absolutely breathtaking number. A teleportation fidelity of 0.9840. That's 98.4% accuracy. This right here, this is the headline. This is the successful engine ignition.
And you've got to understand, this isn't just a good grade. It is profound. See, any fidelity score over about 2/3 or 67% is considered literally impossible to get using just classical physics. So at 98.4%, this result is undeniable. It's ironclad proof that a true quantum phenomenon took place. The physics works. It actually works.
Okay, so this is the crucial question, right? How did they get such a clean, such a perfect result? What was the secret sauce that made this whole experiment so successful? Let's pop the hood and take a look.
Let's just walk through the process. So first, Alice prepares her quantum state. That's the message she wants to send on her qubit. Then an entangled pair of particles is made, and one half goes to Alice, the other half goes to Bob. Here's the cool part. Alice does a measurement on her qubit and her half of the entangled pair. And the moment she does that, Bob's qubit instantly collapses into the exact state Alice sent. It's the precision of that final state that gives us our amazing fidelity score.
So how do we actually get to that 98.4% number? Well, without getting into all the heavy math, the final fidelity score is basically built from two key measurements. You can kind of think of them as two parts of a confirmation signal. The first part came in with a value around 0.55, and the second part was about 0.43. When you combine those two pieces using the right formula, boom, you get that near-perfect result.
And maybe, just maybe, the most important number for the future, for scaling this thing up, is this one. The entire experiment, running over 1,000 times to make sure it was right, took just 1.26 seconds to execute. That isn't just fast, that is a screaming green light that this core process is incredibly efficient and super stable.
So, we've got a successful engine test. What's the payoff? Oh, it's huge. This one result directly de-risks the entire Wormhole v2.2 project. It gives scientists and engineers the confidence they need to actually move forward with building the full-scale Starship.
This slide right here really drives that connection home. On the left, you see the Shannon entropy. which is just a measure of information from our simple little experiment. And on the right, that's the target for the massive wormhole design. The fact that these two numbers are even in the same ballpark is it's incredibly significant. It tells us that the basic physics of transferring information holds up, even when you scale from just a few qubits to over 100. The physics scales.
And that 1.2-second runtime, that is the key to everything. If this basic test had taken minutes or hours, a more complex version would be a total non-starter. But this incredible speed proves the process is efficient enough to build on top of. It really does pave the way for the much more complex circuits needed for the real wormhole.
So now that we know the foundation is solid rock, we can start to confidently build some of the more complex, more abstract ideas on top of it. And this is where the design gets truly futuristic.
One of the wildest concepts built on this foundation is something called Metatron platonic geometry. Okay, in simple terms, it's a way to encode information not just as a boring string of ones and zeros, but as complex geometric shapes. Think about it like embedding an entire 3D blueprint directly into the quantum state of the system.
So how does that even work in the real world? Well, the design uses the Fibonacci sequence. You know that famous pattern we see all over in nature? To assign the points of a geometric shape, like a tetrahedron, to very specific qubits. So the corners of that shape get mapped to qubits numbered 8, 13, 21, and 34. It is an incredibly elegant way to bake a complex structure right into the quantum system.
All right, so let's just quickly sum up what this validation really gives us. Number one, the core principle works, and it works with an incredible 98.4% fidelity. Number two, the speed is there. That 1.26-second execution time is a massive green light. And because of that, number three, the path is now clear. We can build these higher-level, complex structures like Metatron geometry because we know they're sitting on a foundation that has been tested and proven to be solid.
You know, this successful experiment, it isn't just another data point in a lab notebook. It's like a key that has just unlocked the door to a much, much bigger and more ambitious future for how we design things at the quantum level.
And this really leaves us with one final, pretty provocative thought. Proving the most basic, fundamental building block of a cosmic scale idea took just over a single second on the hardware we have today. It really makes you wonder, with this principle now validated, what kind of quantum leaps are we going to see not in 100 years, but in the next 10?